Hi there chemistry students, we've got an A-level chemistry question from year 1 in this video. It's a TOF or a time of flight question linked to atomic structure. It's taken from the AQA specification. Okay, so again, some just factual recall here. We need to describe the process of electrospray ionization. We've also got the graph there, the mass spectroscopy, giving us the abundance and the ions. In this case, we can only see the M over Z of 556, which we'll need to use in the next part of the question. Anyway, back to business. The process of electrospray with an equation. So we're going to get 3 marks for the process if we're going to get 1 mark for the equation. So let's have a little look at the process first of all. We need to dissolve P in a solvent. This is then injected through a needle at high voltage, and then P gains a proton. So the process of P gaining a proton, P plus H plus, the proton there goes to PH plus. Essentially, you include the charge there. If it didn't have charge, it would not be detected. M over Z represents the mass to charge ratio. Okay, so the next part of the question is linked, as is often the case, to the first part, in which we have to deduce the relative molecular mass of P. The M over Z is the mass to charge ratio, so if the charge is 1, then M must be the mass divided by 1. But we also must remember that the molecule of P gained a proton, and because protons have got a relative mass of 1, it tells us that the relative molecular mass must be 1 subtracted from 556, which is 555. Recall also that we can use mass spectroscopy to deduce the masses of the different isotopes in a sample of atoms, but here we're using it to deduce the relative molecular masses. Okay, so now we have the final part of the question, quite a lengthy question, worth 5 marks and a very involved calculation. You might want to spend a little time now by pausing the video, reading the question and perhaps having a go. So the calculation, I will always say with calculations, it really pays dividends to show you're working out fully, and that really doesn't involve your calculator until the final step of each section. Velocity, mass, we've got 2 masses there, so there's probably going to be a unit conversion, and then we've got molar mass, the molar mass of a molecule of Q. So we can get the velocity from distance divided by time. We can get the mass by rearranging the KE expression, the kinetic energy expression given to us in the question. It's always worthwhile rearranging algebraically before you put numbers in if you can. When we're working out molar mass, there's a little clue there that we're going to be working that out in grams per mole. So simply putting the numbers for distance and time into that equation, 1.50 meters is the distance that the ions have travelled, and the 1.23 times 10 to the minus 5 is the time taken to reach the detector. Don't be put off with very big and very small numbers. These ions are moving, well, as you can see, they're incredibly quickly. 1.23 times 10 to the minus 5, not very long at all for it to travel that distance, and as such the velocity in meters per second, do include your units, is quite high. It's traveling at an incredible velocity there. I've retained all of these significant figures in process, just to be careful there, so just retain that in your calculator memory and include at least an extra couple of significant figures than the 3 significant figures for the final answer, so at least 5 significant figures I would suggest there in process. Once again, for the expression for M, we put in the numbers from the question. So the energy is in joules there, 2.09 times 10 to the minus 15, and the velocity squared, well, we worked out the velocity in the previous part of the question. That gives us an answer, remember, in kilograms because it's in SI units. because we need to work out grams per mole in a moment, we're going to need to convert that to grams, and we do that by multiplying by 1,000. You don't want to be in an exam second guessing, oh, is it times 1,000, is it times a million, is it divided by a million? Really get fluent with your unit conversions. That is the mass previously, the 2.8106 times 10 to the minus 22. That's the mass of a single molecule. Now we want the molecular mass, so we need the mass of 1 mole of molecules. So we multiply through by Avogadro's number, which is given to us in the question there. That's 6.022 times 10 to the 23. And that's going to give us our answer in grams per mole. 169 to 3 significant figures. I've retained the same number of significant figures as the fewest number of variables given to us in the question. Any comments welcome in the chat. Any requests for future videos, just let me know. Thank you.